Section 9.1, Inferences for Regression, video number 6. It's time that I introduce you to a new measurement called coefficient of determination. And the variable for coefficient of determination is r squared. Yes, this is the same as the r squared in the computer output. And yes, it is the square of correlation. The square of correlation. So if you know what r equals, you square it and you get r squared. Now, why does r squared get its own time in the spotlight? Because r squared measures something. When you have a model, when you have a regression equation where you're attempting to predict the value of a response variable based on the value of an explanatory variable, there are other things you are not considering. For example, if you are trying to predict the price of a printer, its printing speed can be one of the variables. It could also be the quality of the printing, how much it costs per page, and other things that are escaping me right now. But there are other things that could affect the price of a printer, maybe the brand of the printer. I know brand is qualitative. How do we quantify that? Again, when we get to chapter 10, I'll explain how to take a qualitative variable and treat it like a quantitative variable. But there are other things that can affect the price of a printer besides how fast it prints in pages per minute. According to the computer output, the value of r squared, which the author uses a capital R, the output uses a capital R, the value of r squared is 54.7%. But what does that mean? On your next test, you will be asked to interpret the value of r squared. Interpret this value. And it's actually really easy to do. But I should tell you what r squared measures in general. R squared is the percent of variability in the response variable that is explained by the explanatory variable. In other words, when the response variable changes, what percent of that change can be attributed to the explanatory variable? In this case, the answer is 54.7%. So, how do you interpret an r squared? You can always interpret it like this. Blank percent of variability in blank is explained by blank. This is a template for interpreting what r squared means. Some percent of variability in something is explained by something. The value that goes in this blank clearly is going to be the value of r squared. Excuse me. I promise you it's allergies, not coronavirus. The value that goes here is just the value of r squared. So 54.7% of variability in. The value that goes here will always be the response variable. In this case, price. And the value that goes in this blank will always be the explanatory variable, which is printing speed. I know it says ppm, but it's measuring printing speed. So to interpret this value, we could say that 54.7% of variability in the price is explained by the printing speed, which also means that 45.3% of variability is explained by something that the model doesn't represent. Remember that error term earlier? That's what it's accounting for. The other 45.3% of stuff that affects the variability of the printing speed, the variability of the price, besides the printing speed. So it's a fairly quick and easy interpretation. You can just write this sentence and fill in the 3 blanks with the value of r squared, the response variable, and the explanatory variable.